Now moving on to example 8, we can see this beam here. We have already calculated the reactions of this beam in assignment 02. Now we need to plug those reactions here. So plugging these reactions, this beam has an internal hinge. So, and as we cannot see any axial loading or horizontal loads here, there will be no axial force diagram. So let's start with shear force diagram first. So drawing the vertical lines and a horizontal line starting from point A. At point A we can see here a reaction acting upward, and the value is 6, so we have to rise an amount of 6. So in between A and B there is no loadings, so the line will be a continuous one. At point B we can see here the point load of 12 kN acting downward, so the sum will be positive 6, as the initial value was positive 6, and then here it's facing negative 12, so 6 minus 12, which is negative 6. So we need to move towards negative 6, which is around here. So selecting this point and drawing the line. Now moving from B to C point. So in between B to C there is no loadings, so the line will be continuous line. Now at starting from point C we can see here 2 kN per meter load along a length of 6 meter. So the total load will be 12 kilonewton. So from this C portion, from this C point, while moving to D point, we need to sum up the load. Initially it was negative 6 and it is facing another negative 12 as it is acting downward. So negative 6, negative 12, in total the summation will be minus 18. So we need to select the minus 18 point around here. So minus 18, and as the area is uniform or the loading pattern is uniform, the line will be an inclined one. So we are drawing an inclined line here. Now at point D there is a reaction 18 acting upward, so we need to move upward 18, negative 18 plus 18, it will be 0. So in this way we'll draw the shear force diagram, and before drawing the bending moment diagram we need to calculate the area first. So the area of this portion will be, as usual, height into base. We can calculate this area also, and here we can see a trapezoidal area, and we know the formula of trapezoid, so we can easily calculate the area of trapezoid. Half into length between two equal sides and the summation of lengths of two sides. So from here we are getting the area is minus 72, and we can do also another thing, which is we can divide this area into two portions. So we know the value of this height will be minus 6, so this amount will be minus 12. Now we can see minus 6 into 6, which is minus 36, and minus 12 into half, as this is a triangular one, so minus 12 into 12 into 6 into half, it means another negative 36. So if we add negative 36 and negative 36, we will get the value of minus 72. So in this way we also can calculate the value of this area. So now summing up the areas, we will draw the bending moment diagram starting from this point, and while moving to this point we can see the summation will be initially 0 and positive 18, so the sum will be positive 18. As the area is an uniform one, it will be an inclined line, so this inclined line here. Now moving from this point to this line, or this point, moving from B to C point, we can see it's facing an area of negative 18, another negative 18, So initially it was 18 and negative 18. So at point C the sum will be positive 18 minus 18, which is 0, 0. So we are moving to this 0 point. As the area is uniform, the line will be an inclined one. Now here we can see a trapezoidal area. It will be same as the triangular area. We know for triangular area the line always be an curvilinear one. So for trapezoidal area the line will also be the curvilinear one. So before that we need to sum up the area. So moving from C to D point, in C this initial value was 0, and moving to D point it's facing negative 72, so the sum will be 0 minus 72, which is minus 72. So we need to select the point minus 72, and from the area we can see it's in negative portion, so negative, and the shape while moving from C to D the shape is increasing, so negative, increasing. So here the curve will be this one. So we need to draw something like this one. Actually it has bended, so just plugging this line here, we can see this line here. So in total now we have reached to minus 72, but still we can see here a support reaction which is clockwise 72. We know that this clockwise represents positive, so we are in negative 72, and it's facing a moment of 72. In other cases or in other examples there were no moments, but here we can see it's facing a moment of 72 kilonewton meter, which is positive. So we are at negative point minus 72, and it's facing another plus 72, where it will be minus 72 plus 72. In total it will be 0. So we need to move towards 0 point. In this way we can conclude the bending moment diagram for example 8. Now for example 9, it's actually the same. I hope you'll be able to solve this problem. Let's see example 10. In example 9 you need to divide it into two components. First, for this inclined load, we had shown this how to calculate this reaction in your assignment 02. So you need to plug the reactions first and draw the shear force axial. As you can see here, axial force, so we need to draw the axial force, shear force, and bending moment diagrams as well. Hope you'll be able to calculate these values. Now let's see example 9. Example 10. In this example 10, here is an external moment, extra moment. So this moment will be add up in the bending moment diagram and not in the shear force diagram. As we know that in shear force diagram we just deal with the vertical forces or vertical loadings, and in axial force diagram we deal with the axial forces or the lateral or horizontal forces, whichever we may say. So let's draw. Before that we need to calculate the support reactions for this beam. So using the equation of equilibrium we have calculated this support reaction. We will get the support reaction here positive 2. As we cannot see any inclined or horizontal forces along this AE beam, so here the value of AX will be 0. As in rollers, as there is a roller support, we will get a vertical reaction here 7. Now let's draw the shear force diagram. Before drawing the shear force diagram we need to draw a horizontal, we need to draw the vertical lines at the starting point and ending point of the loadings, and at supports, and at the moment where there is an external moment at that point also. So now let's draw the shear force diagram. In shear force diagram, starting from point A, you can see it's facing a load to upward, so moving to upward 2. Now we need to move from A to B. So in between A to B, here we can see an uniformly distributed load, and for this 2 kilonewton per meter uniformly distributed load, the total load was 6. So the summation up to B point, the summation of load will be, initially it was 2 and it's facing -6, so 2 minus 6 minus 4, which will be around this point. So minus 4. As the area is uniform, the line will be an inclined one. Before drawing the bending moment diagram, you need to calculate the base of this 2 portion. As we can see, it's been intersected at this point. So while drawing the bending moment diagram, you need to draw the vertical line along this intersected point and calculate the base first and then the area. Okay, let's complete the shear force diagram. Moving from B to C point, we can see no loads, so the line will be continuous, and up to D point there is no load. Here is a moment, but we know that this moment will not come in shear force diagram. It will rather go on or come in our bending moment diagram. So B2, in between B to D there is no loadings, so the line will be a continuous one. At point D, it's facing an 7 kilonewton reaction or load upward, so -4 plus 7, in total it will be +3. Now as we can see here, for this 2 kilonewton per meter uniformly varying load, the total load will be 3 kilonewton. So for 3 kilonewton we need to sum up the loadings first. So while moving from D to E, initially the value was 3 and it's facing -3, so the total will be +3 minus 3, which is 0. So 0 point. But before that, while drawing the line, we need to consider the shape of the area and the loading patterns. So here you can see the load is triangular one. So as we know that if the loading is triangular or the area is triangular, the bending moment line, the line will be either, for shear force or bending moment, the line will be a curvilinear. In all cases, if the loading pattern is triangular or the area is triangular, whatever we may say, the line will always be a curvilinear one. So we know there are 4 types of curvilinear lines. So as we can see here, the shape is increasing but the load is acting downward. That means as it is acting downward, it will be negative. Okay, and as the shape is increasing while we are moving from D to E point, the shape is increasing but it's acting downward, the load is acting downward, so we have taken negative, and the shape is increasing, so it will be negative increasing. Most of you guys in your exam will face this problem or forgot to consider it as negative. But as we know that if the loading is negative, we need to consider it as negative. So negative, and as the shape is increasing, so negative increasing, so the line will be this one. So as the summation is 3 and -3, which is 0, 3 0, so this will be, we have selected this line, so just plugging this line here, we will complete our shear force diagram. So here are the values of slopes. You don't need to show these things in your diagram. Okay, so before drawing the bending moment diagram, you need to calculate the area first and draw a vertical line through this intersecting point, and then using the same principle or the rule of triangle, symmetrical triangle, you need to calculate the bases 1 meter and 2 meter. We have shown in example 7 or 8. So we have calculated the base 1 and 2, and then we need to calculate the areas areas. So for this portion, the formula of area will be 2 by third BH. So applying this 2 by third BH, we can see the base is 3 meter and height is 3 meter. So 2 by 3 into 3 into 3 in total, it will be 6. So the area will be 6 for this section. Positive 6. We have calculated each of the areas. For this smaller portion, the area is 1. For this one, -4, -12, -12, and 6, 2 by third BH. So now drawing the bending moment diagram. So as it is in positive portion, so positive decreasing, shape is decreasing, so the line will be something like this one. So we are drawing the line here, taking the sum of the area. You can see positive 1. So we can, I think you can draw up to this point. Similarly we are drawing up to this point, and as the line is while moving from B to C point, it's facing a area of -12. So -3, -12, it will be -15. So the line, as the area is uniform, the line will be inclined. But at C point, as it is facing a moment, and this moment is and the moment is clockwise moment. So we know that if there is a clockwise moment, we need to consider it as positive. So here the value is -15, and we can see here an external moment, and for this external moment it will affect our bending moment diagram, and it will add up with this diagram. So sum up with this diagram. So -15, and as the moment is clockwise, so -15 plus 21. This clockwise represents positive moment, so -15 plus 21 will be +6. So we need to jump to 0.6. So we can summarize that if there is an external moment, there will always be a jump in our bending moment diagram. So now we can complete this diagram. While moving from C to D point, facing an area of -12, 6 minus 12 will be -6. The line will be inclined as the area is uniform. Now while moving from D to E point, we can see the sum of the area will be -6 plus 6 equals to 0, this point, and the shape of this area is decreasing, and it is in positive portion, so it will be positive. This area is in positive portion, so positive, and you can see the shape from while moving from D to E, the shape is decreasing, so it will be positive decreasing. So just plugging this curve here, we're drawing this curve here. In this way we will conclude the bending moment diagram. So now if you were asked to calculate the maximum bending moment for this beam, you can easily conclude that the maximum bending moment is negative or -15 kilonewton meter. So this was all for diagram method. Thank you.